All right, so let's talk about some various properties of logarithms. So let's look at an example first. So I have log base 2 of 32. So 2 raised to what power is 32? Obviously the answer is 5. Okay, let's do this a different way though. Let's do log base 2, 32 in a different manner. So 32 you can rewrite as 8 times 4. So I'm going to do that. Log base 2 of 8 times 4. All right, now I'm going to do something strange. I'm going to break this logarithm apart. So I'm going to turn this into log base 2 of 8 plus log base 2 of 4. Okay, now you should be at this point asking, why can I do that? I mean, how do I know I can do that? But for right now, let's just see if it works. Okay, so what's log base 2 of 8? Well, that's 3. What's log base 2 of 4? That's 2. And 3 plus 2 is 5. So I get the same answer either way. So it worked this time, but how do we know it always works? Am I really justified in breaking this apart like this? So let's see if we can prove that this is always true. That if I have log with some base of a number times a number, then I can turn it into this sum like this. Let's see if we can prove that. All right, so here's rule number 1. I have log base b of x times y is going to equal log base b of x plus log base b of y. Hey, let's prove that this rule is really true, that it works. All right, so the first thing I'm going to do is give both of these terms a name. Okay, so I'm going to say log base b of x equals j. So I'm just giving it a name. It equals something, we'll call that something j. And I'm going to name the second one. So log base b of y, we'll call that k. All right, notice that in this rule, at some point in here, I wanted x times y. Okay, I want those, or excuse me, let's do something else first. All right, so step number 1 is I name these guys. Okay, now I'm just going to tell what each one of these means. So what does this mean? Log base b of x equals j, by definition means b raised to the j equals k, or not k, sorry, I'm messing all up this morning. Let's try this again. B raised to the j equals x. B raised to the j equals x. Now this one means b raised to the k equals y. That's an ugly looking k. I'm not doing well this morning at all. All right, so I gave both of these terms names, then I told what each one of those meant. All right, now notice that in this rule I have an x times a y. Okay, so how can I combine these in some way so that I get something that's over there? I know that I need an x times y at some point, so let's just do that. Okay, let's do x times y. Okay, so x times y, what would that equal? Well, my x is b to the j, and my y is b to the k. So I just wrote down x times y. What does x times y have to be equal to? Well, x is b to the j, and y is b to the k, so x times y has to equal b to the j times b to the k. All right? I have exponent rules. Same base. I'm multiplying these together, so what do I do to the exponents? Well, I add those exponents. So I have b to the j plus k. Now, notice that in the rule that we're trying to prove, I have log base b of x times y. And then I got some logs over here. Here, I have an x times y. Here I need a log base b of x times y. So what if we just took the log base b of both sides? Okay, so I'm going to do the log base b of this side, and I'm going to do log base b of this side. Okay, so the log base b of both sides. Okay, so here I have what I want, log base b of x times y. Alright, over here I have log base b of b raised to the j plus k. So remember, as we talked about before, the answer to this would just be j plus k, because b raised to the j plus k is equal to b to the j plus k. So this side would just be j plus k. Alright, we're almost there. What is j? Well, j was log base b of x. What is k? That's log base b of y. So let's fill in the blanks. Log base b of x times y has to equal log base b of j is log base b of x plus, and k is log base b of y. And we have proven the rule that we want to prove. Alright, so our next rule, log base b of x over y, is going to equal log base b of x minus log base b of y. So multiplication results in an addition, division results in a subtraction. So I want you guys to try to prove this. It's very similar to the first one. So pause the video and you guys try to prove this, and then we'll go over the solutions. Alright, so hopefully you were successful with that, and maybe you saw that it was really kind of a lot of fun. It was really neat to prove that. Alright, so the first step, we're going to give each of these terms a name. So log base b of x, I'm going to call that smiley. Okay, log base b of y, I'm going to call that frowny. Step number 2, I'm going to tell what each of these means. Okay, so this means b raised to the smiley equals x. This one means b raised to the frowny equals y. Alright, and now I notice that in my rule I have an x over y, so that's what I'm going to do. I'm just going to say x over y equals, now what will that equal? Well, x is b to the smiley, so that'll be b to the smiley, over y is b to the frowny. So I have x over y equals, now exponent rule, same base, I'm dividing, says I subtract those exponents. So this will be b raised to the smiley minus frowny. Right, now I'm going to take the log base b of both sides because that's what I want, log base b of x over y. So log base b of x over y on this side, and log base b of b raised to the smiley minus frowny. So then I have log base b of x over y equals, well, b raised to what gives me b raised to the smiley minus frowny. Obviously that'll be smiley minus frowny. Well, what is smiley? Smiley is log base b of x, frowny is log base b of y. So finally I have log base b of x over y equals smiley is log base b of x minus brownie is log base b of y. And I've proven this rule. Alright, so let's have a look at our third rule. We have log base b of x to the m power, x to the m is in parentheses. That's going to equal m times log base b of x. So notice this exponent comes down to the front. That. Okay, let's see if we can prove this rule. Alright, so the first thing I'm going to do is give log base b of x to the m a name. Right, so log base b of x to the m. Let's call that, what do we want to call it? Let's call it j again. Doesn't matter. Right. And the next thing I'm going to do is give log base b of x. So I'm going to kind of ignore the m. And I'm going to say that log base b of x equals, let's call that r. Right. Second step, as before, I'm just going to tell what each of these means. Right. So this one means b to the j equals x to the m. This one means b to the r equals x. Alright. So now what can I do? How can I combine these in some way? Notice here, I know what x is. X is b to the r. So what if I substituted this value of x for this x right here? And let's see what happens if I do that. So in that case, I'll have b to the j equals, now I'm going to substitute this value of x in for that. So I'll have b to the r raised to the m power. Right, so this value of x is equal to b to the r, so I'll put it right here, b to the r to the m. Right. Let's take the log base b, or before we do that, what do I do to these exponents? I multiply these guys, right? So r times m or m times r. So that'll be b raised to the m times r. Right, now I'm going to take the log base b of both sides. So log base b, b to the j, is equal to log base b of b to the m times r. Alright, log base b of b to the j is just j. Log base b of b to the m times r is just m times r. Alright, well what was j? J was log base b of x to the m. There's m. And what was r? R was log base b x. And we have proven the rule. That's exactly what we were wanting to prove. Alright, let's look at an example of this and see if it really works. Alright, so here's an example. Let's do log base 2 of 4 to the third power. Okay, so that looks exactly like this, 4 to the third. So my m is 3. Okay, if this rule is true, and it is true because we just proved it, we know it's going to be true, we know this is going to work, but let's just see it in action. Okay, so this says that if I have log base 2 of 4 to the third, that should equal 3 times log base 2 of 4. That 3 should come down to the front. Let's check and see if that really works. Alright, so here I have log base 2 of 4 to the third. 4 to the third is 64. So that's log base 2 of 64. 4 times 4 times 4 is 64. Alright, log base 2 of 64 is 6. 2 to the 6th power is 64. Over here, I have 3 times log base 2 of 4 is 2. And 3 times 2 is 6. So you can see an example of that rule in action. All right, so our final property of logarithms is very important. This is called or known as the change of base formula. The reason for that, notice, is because if I start in one base, base B, I can change it to any base I want, base C. So I might start in log base 5, and if I wanted to change that to log base 7 for some reason, your C would be 7, and this would tell you how to do it. So I can change from any base to any other base using this formula. So let's see if we can prove this. All right, so again, to prove it, same general strategy as before. I'm going to give each of those terms a name, tell what they mean, and then see if I can do some kind of algebraic manipulation to get it in the form I want. So let's call log base B of x, let's call that J. All right, log base C of x, let's call that K. And log base C of B, let's call that R. All right, then let's tell what each one of these means. So this one means B to the J equals X. This one means C to the K equals X. And this one means C to the R equals B. All right, now let's see what we can do to these. How can we combine these some way algebraically to get what we want? Okay, so the first thing I notice is that I have two x's here. I know that x is equal to this and x is equal to that. So if x is equal to b to the j and x is also equal to c to the k, then I know that b to the j has to equal c to the k. Right, so let's write that down. B to the j is equal to c raised to the k. All right, what else do I know? How can I use this third equation? Well, here I have a value of b. b is equal to c raised to the r. So maybe I can substitute this value of b right here. Let's do that. So if I substitute this value of b, I'll have c to the r power to the j power is equal to c raised to the k. I know what to do to these exponents. I can multiply those. So I have c to the rj equals c to the k. Right? And I know how to solve this equation. Now I'm going to take log base c of both sides. So log base c of c to the rj equals log base c of c to the k. Okay, so I know this will give me rj, and I know this will give me k. So I know that r times j is equal to k. All right, what is r? R is log base c of b. J is log base b of x. Notice that I want log base b of x by itself. Okay, so I'm going to log base b of x. I'm going to divide both sides by r. So I'll have j is equal to k over r. All right, then final step that I don't have room for there. Let's go over here. J is log base b of x. K is log base c of x. And r is log base c of b. Hey, and that's what we were trying to prove. So we have proven the change of base formula. All right, let's put our change of base formula into practice. So I have log base 5 of 17. Say I want to rewrite that in terms of log base 2. Okay, so log base 2. All right, so I'm going to use my change of base formula. So my b is 5 and my x is 17. I want to change it to log base 2. So my c will be a 2. Okay, so I'll have log base 2 of x, which was 17, over log base 2 of b, and my b was a 5. So it's that easy. I rewrote that in terms of log base 2. So if I had a question that was base 5, log base 5, and for some reason I wanted it as log base 2, I would just use this formula, and it's as easy as that. All right, let's rewrite it in terms of the common log, or log base 10. So my new base would be base 10, but we don't have to write the 10, it's understood. So that would just be the log of 17 over the log of 5. And it's just that easy. Okay. On your calculator, on the main screen, you have a button for the common log. Okay. It's more difficult on the calculator to do base 5. You can do it, but you have to search through some stuff. So an easy way to do log base 5 with 17 would be to use the change of base formula and just type in your calculator log of 17 divided by log of 5, and it would give you an approximate value for that answer. All right, another way that we want to rewrite things a lot, we like things in natural log. So let's rewrite it in log base e. Okay, so I could change to log base e here and here, but our abbreviation for that is natural log, so I can just write the natural log of 17 over the natural log of 5. So it's that easy to change your base. If you want to change it to natural log, you can just do the natural log of 17 divided by the natural log of 5. All right, so here's a really fun question. So let's pretend that log base b of 4 is equal to smiley and log base b of 3 is equal to frowny. Okay, I want to rewrite, that should be a 2, that should be a b. I want to rewrite log base b of 144 in terms of smiley and frowny. All right, so how do I go about this? So first of all, I need to find some relation between 144, 4, and 3. So 144, that rings some bells. I know that that's 12 squared. Okay, so let's do that. Log base b of 12 squared. I have a logarithm rule, number 3 here, that tells me how I can rewrite that. I can move this exponent down to the front. So I'm going to put 2 log base b 12. All right. Now I have a 12, and that's related to a 4 and a 3, so I can rewrite that as 2 times log base b of 4 times 3. Right. I have a rule now that tells me how to handle that. Log base b of 4 times 3 would be log base b of 4 plus log base b of 3. Right. So I'll have 2 times log base b of 4 plus log base b of 3. Right. Log base b of 4 is smiley, so I'll have 2 times smiley plus log base b of 3 is frowny. That. So I've rewritten log base b of 144 in terms of smiley and frowny.